Okay, so this would be the last video. And one skill you need to be able to do is use a calculator to approximate trig values not on the unit circle. And it says watch your mode because the calculator needs to know whether you're in degrees or radians. Okay. Okay, so or radians. Now I'm going to pull up a calculator that I like to use. And that one is, you can find it at calculator.net, and it's scientific calculator. Okay, so I'm going to do, first of all, cosine of pi over 8. So we go cosine of, and there's my pi divided by 8. Okay, so it says cosine of pi divided by 8. Oops, I did times 8. Okay, it's all right. We can go right back there. And we'll just clear it. Okay, so first of all, is pi divided by 8 degrees or radians? It's radians, so we have to do radians. And every calculator has a different way to do mode. So cosine pi divided by 8. And there it is. Okay, so it's 0.92. And that's the, see, I don't think I can draw on here. No, I can't, but okay. So the next one was cosine of 36 degrees, so I would have to go back to degrees and then go to, oops, I don't need that, and then go to cosine of 36. And then I'm going to write this down. So that's 0.809. You want to be at least 3 decimals clear, okay? And then the next one on your lecture sheet is sine of 180 degrees. Now, sine of 180 degrees, I can do without a calculator because that's the y coordinate of 180 degrees, and that's 0. But let's prove it right here just to show. So we want the sine of 180 degrees, and oops, I didn't clear. Clear. Okay, sine of 180 degrees, and there's my 0. Okay, you can test this all out. You could do the cosine of 180 degrees, and that should be -1, right? Cosine 180 degrees. Oh, you got to clear it, Marge. Cosine of 180 degrees, and that should give me, I'm going to put in right. Cosine 180 is -1. Okay, so then it says the sine of pi over 8. I got to go back to radians. Okay, so sine, shoot, clear. Radians, sine of pi divided by 8, and that's the same, and that's not the same, that's the same value or same angle as we started with, only the sine is 0.383. I'm going to round that off. Whereas the cosine, clear, cosine of pi divided by 8 was 0.924. And I'm going to talk about that when I get back to the notes. Okay, so sine of 36, got to go back to degrees, clear it, sine 36, you get the drift here. Okay, 0.5878. Now, when you do your homework, pay attention to how many decimals they want you to use, at least 3. And the last is radians cosine, oops, clear, cosine of 3 pi divided by 7. Okay, and that's 0.22. All right, so I'm going to go back to the notes. All right, so when I said the cosine of pi over 8 was 0.924, and the sine of pi over 8 was 0.383, let's just see what that means. That means that if you're on the unit circle and you go to pi over 8, now we know this is 8 pi over 8. And so we're going to cut these in 8ths. So that's 4ths, like this would be 4ths, and then cut those. So pi over 8 is right here. And if you're on the unit circle, that point has a cosine of 0.924 and a sine of 0.383. What does that mean? That means that you go from the origin, you would go right, you would go right 0.9, which is almost to this 0.10, okay? Go way over here to 0.924, and then you would go up 0.383, which is just about a little bit less than half. And that's what the cosine and the sine, that's what those values mean. It's how far you go on the x-axis for the cosine and how far on the y-axis to get to that angle, okay? Just so you know. All right, now if we're not on the unit circle, we have to multiply the sine and the cosine by the radius to get the actual distance. So for example, on a circle of radius 5, let's say, now here's the unit circle, is really small in here, but we're going to go out 2, 3, 4, 5. This is a bigger circle. There is a 0.34 at some angle theta. We want to know what's the cosine and what's the sine of that. So here's the point 1, 2, 3, 1, 2, 3, 4, right there. And we want to know what the cosine and the sine of that point are. So we have these two. Instead of just x being the cosine and y being the sine, we have to times it by the radius, okay? So we know that radius is, so we know, first of all, we know that 3, 4 is the actual point. So we know our x is 3 and our y is 4, and we know our radius is 5. Okay, so the Pythagorean theorem can be used on any point on any circle if you know the radius, because we have this right triangle right here. This is 3, this is 4, and this is 5. Okay, so the cosine is going to be the x divided by r, and the sine of the angle is going to be the y divided by the radius. So in this circle, we have x is 3, radius is 5, so the cosine of that angle is 3/5. That means on the unit circle, I would go out 3/5 on the x-axis, and the sine would be 4/5. So here's my unit circle, 1, 0. And so for that point, on the same big circle, at that angle, this angle right here is the same angle here. So my cosine would be 3/5 and my sine would be 4/5. And that would be that point right there, 3/5, 4/5. Okay. So, well, let's do an example. If we know what the cosine is, we need to find the sine. Okay, so the cosine is, if you remember, it's x over r, and the sine is going to be y over r. So we know the cosine is 5 over 8, so that means x equals 5 and r equals 8. And to find the sine, we need y. So we're going to use that Pythagorean theorem for the equation of a circle, which is x squared plus y squared equals r squared. So x is 5 plus y squared, and radius is 8. So we'll get 25 plus y squared equals 64 minus your 25, and we'll get y squared equals 14 minus 5 is 9, 39. So y would be plus or minus the square root of 39. And it could be plus or minus. It kind of depends on which quadrant the angle is in. Okay, so the sine is going to be the square root of 39 plus or minus over 8, because it's y over r. And if the angle was in quadrant 1, it would be a positive 39 over r up here. And if the sine was in quadrant 2, it would be a positive radical 39 over 8. If the sine was in quadrant, or if the angle was in quadrant 3, it would be the negative. And quadrant 4, the signs are both negative. So the sign is positive up here, and then the sign would be negative down here. Okay. So what I'd like you to do is be able to visualize these. If you think of the cosine, so think about pi over 6, which quadrant is it in? Well, it's right here somewhere. Is the cosine positive or negative? Well, the cosine is the x-coordinate, so it's positive. And we actually know that one because it's on the unit circle, and that would be the cosine is positive radical 3 over 2. All right, let's look at 80 degrees. If I want to find the cosine, still in quadrant 1, 80 degrees is about here, and the cosine is going to be positive. Sine of 185 degrees. So first, where is 185 degrees? Well, here's 180, so it's going to be in quadrant 3. Is the sign positive or negative? Well, the cosine's negative and the sine is negative. So we just want to visualize that's in quadrant 3, and it's got a negative sign. How about 3 pi over 4? Which quadrant is it in? Right here. So it's in quadrant 2, and the sign is the y-coordinate, so it's positive because it's up. Let's look at 300. So this is 180, this is 270 degrees. So 300 is going to be in quadrant 4. And is the sign positive or negative? Cosine positive, sine negative. And let's look at 7 pi over 6. And I always go to pi, which is 6 pi over 6. So 7 pi over 6 is going to be quadrant 3. And the cosine and the sine are both negative. There we go. Okay, so hopefully you can follow that and visualize that. One more thing, let's do an application. Okay, this is in your textbook, which you can read after these videos and clarify some things, goes a little more into depth on examples. So a distress signal is sent from a sailboat during a storm, but the transmission is unclear. The rescue boat sitting at the marina cannot determine the sailboat's location. Using high-powered radar, they determine the distress signal is coming from a distance of 20 miles and an angle of 225 degrees from the marina. How many miles east, west, and north-south of the rescue boat is the stranded sailboat? Okay, we want to know how far do we need to go west and how far do we need to go south, okay? And that's what they want to know. So it's going to be west and south. And all we know is the distance here is 20, and we know the degrees. So what they really want is the x-coordinate and the y-coordinate of that point at 225 degrees and 20 miles out. We're going to call the radius 20 miles, okay? And now we know that x equals r times the cosine of theta, and y equals r times the sine of theta. Well, we know that x equals 20 is the radius, and we need the cosine of 225 degrees. And if you remember on our unit circle, that's a fourth because it's right smack down the middle. And the cosine is going to be negative in quadrant 3. So this point has a cosine of negative radical 2 over 2 and a sine of negative radical 2 over 2. So we're going to take 20 times the cosine of 225 degrees is negative radical 2 over 2. And we'll cancel the 2 in there, and it's going to be negative 10 times the square root of 2, and they're not going to know what that is. And, they want to know miles, so we're going to do that on the calculator. 10 times the radical 2, and I get a 14.14 miles, and that's going west. And it's actually going to be similar here, 20 times the sine of, because the sine of 225 degrees is also negative radical 2 over 2. So it's going to be 14.14 miles west and 14.14 miles south. And that's what you would tell them to find the stranded sailboat. Okay, so there's one application using the sine and the cosine. Once you know the radius, if you know the angle, we know the cosine is the x, the sine is the y. Okay, and that's the end of this section.